So very good morning, students. So welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches along with your class 8th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Our ongoing chapter, sound and wave motion. And today we are entering into the session number 3. Means so far we completed 2 sessions, 2 classes in understanding the 2 important concepts, that is sound and wave. Right? Sound and wave. We learn about, in first session, we discussed about what is sound, how it is influenced on your eardrums, what kind of sounds you can able to hear, right? And how it is produced, how it is travel, what is the requirement of sound for the propagation, all these things. Then in the last class, we discussed about the wave. So wave is the disturbance created in the medium. Either medium may be solid, liquid or gas. When you create some disturbance, the disturbance propagates forward. Disturbance travels. No particle will travel. Disturbance travel by transferring of energy. And that way, wave formation takes place, and that is called wave motion. Movement of the wave from the point of disturbance is called wave motion. So when you discuss about the wave motion, we discuss about very important terms, right? What is wavelength? Right? What is frequency, wave frequency? Okay, then what is amplitude? And what is velocity, wave velocity? All these things we learn in the relationship part of we have seen. So we know wave velocity is equal to distance by time generally. But what is distance of the wave is nothing but wavelength. Wavelength by time. So V is equal to lambda by t, that is time period. Even time period also one of the important. That is lambda into 1 by t. 1 by t is nothing but frequency, that is lambda into n. So we got the formula V is equal to n lambda. Lambda is a symbol for the, n is a symbol for frequency, lambda is a symbol for wavelength. That is the relationship between the terms used related to wave motion. Right. Till then we have discussed in the earlier class. So we'll continue where we left in the last class. And so when you move forward, so these are the so many ways to produce the sound, the source of sound, right? All the artificial sources. Then we started this chapter here, and we are continued after knowing about the periodic motions. Then we enter into the wave motion. Then when you are discussing about wave motion, we discuss about the various parameters of wave motion, as that is time, wavelength, time period, frequency, wave, that is velocity, and all these things we discuss in the, and whenever sound is produced, it propagates, it transmits in the form of mechanical waves or electromagnetic waves. So mechanical waves are those which can travel only through medium. Mechanical waves cannot travel through vacuum like sound waves. Whereas electromagnetic waves like light waves can travel through even vacuum also. Okay. So there is a transmission of energy takes place through vacuum or through medium. Based on that, the waves are classified into mechanical waves and electromagnetic waves. So when you discuss about these waves, So there are two types of waves you can see, right? So first you can see here, back to first wave is longitudinal waves. What is the first wave? Just a minute. The first type of wave is longitudinal, right? Longitudinal waves. So what is longitudinal waves? Consider a long spring clamped at one end and placed on the horizontal surface. So take one spring, spiral spring, right? It is clamped here, fixed on table we kept. So surface of the straight position as shown. The distance between any two of the joint rings along the length of the spring is constant. Like this should be. So stretching of spring, when you stretch the spring, we can see, for example, when you elongate, they expand. When you release, they come closer. So like that, you can form the different shapes. Sometimes there is a compression, sometimes there is a rarefaction. Compression, rarefaction, compression, rarefaction. That kind of waves where all the particles of medium propagates parallel to the original direction, parallel to their propagation is called parallel. All the particles move parallel. Blindly remember, all the particles of medium propagates parallel to the direction of wave are called longitudinal waves. Longitudinal waves. You can see here examples. See here, all the particles are away from each other. All the particles are close here. Same in case, for example, when you go to cycle shop, air pumps, maybe nowadays we are not seeing. When you are sending air into the tire, when you are pressing the handle, all the air particles are compressed. When you take it out, withdraw it, all the particles are rarefied. You cannot see them, but you can feel it. So when there is compressed is there, you can find the, see, for example, a wave looks like this. This is one case. Again, away from each other, again close to each other. So this is the part where all air particles are closely packed. They are called compressions. What they are called? Compressions. So here also compressions. But here the particles are rarefied. So they are called rarefactions. Factions, not fractions. Rarefactions. So like that, in longitudinal waves, alternate compressions, rarefactions are formed. Compression, rarefaction, compression, rarefaction. Okay. So in details we'll discuss. I will see in the video and also we'll discuss. The second type of wave is transverse wave. Transverse. Right. So here, see here. So transverse wave we take long string along the horizontal position and vibrate. Rope also. Tie rope at one end and start vibrating like this. So actual direction is this one. You tied here. Actual direction of wave is this direction. But when you pluck it here, it will move like this. You see, remember? So what is happening here? Every particle is perpendicular to the original direction. Parallel means longitudinal. Perpendicular means perpendicular or right angle. So a wave in which all the particles of medium vibrates perpendicular or right angle to the direction of wave is called transverse wave. See, here there is a highest peak, upward displacement. They are called crest. And lowest is trough. So crest, trough. Like this, crest and troughs are formed alternately. Right? Sets of crest and troughs are formed in case of transverse wave. So there are two types of mechanical waves. The two types of mechanical waves in which one wave, all the particles of medium propagates parallel to the direction of propagation called longitudinal waves. In one waves, all the particles of moves perpendicular to the direction of propagation called longitudinal waves. In transverse waves, transverse waves, sets of crest and troughs are formed. In longitudinal waves, sets of compressions and rarefactions are formed. Okay, so before going for the differences and all, let me show you one video on this. Then later we'll discuss about the in details about the waves. That is the tabular form.
And wave properties. Why are we able to see? We can see because there's light. And what is light? Well, light is a wave. So then, what is a wave? Well, we will learn the answer to that question today. Have you ever gotten a sunburn? Or used a microwave to make popcorn? Or had an x-ray taken? Or listened to the radio? What do these activities have in common? Well, all of these require waves. One difference between the waves to pop popcorn and the waves to tan your skin is the wave frequency. The frequency of a wave is defined as the number of cycles that pass a single point in a given amount of time. A wave is a disturbance that carries energy from one place to another. Matter is not carried with the wave. A wave can move through matter, which is called a medium, but some waves do not need a medium to be able to move. If a wave needs a medium, we call it a mechanical wave. If a wave can travel without a medium, for example, through space, we call it an electromagnetic wave.
This is two types of mediums classified based on the whether they require medium or doesn't require. Those who doesn't need medium are called mechanical waves like sound. Those who does not require medium are called electromagnetic waves called light.
Wave. There are two types of waves, transverse and longitudinal waves. Transverse waves are waves in which the medium moves at right angles to the direction of the wave. Think about when spectators do a stadium wave. The people are moving up and down, but the wave is going around the stadium. A transverse wave has a crest and a trough. The crest is the highest point of the wave and the trough is the lowest point of the wave. Longitudinal waves, also called compressional waves, are waves in which the medium moves back and forth in the same direction as the wave. While a transverse wave has a crest and a trough, longitudinal waves have compressions and rarefactions. A compression is where the particles are close together, and a rarefaction is where the particles are spread apart. Waves also have different properties associated with them. Wave properties depend on what type of energy makes the wave. These wave properties include wavelength, frequency, amplitude, and wave speed. Let's dive a little deeper into each of these properties. Wavelength is the distance between one point on a wave and the exact same place on the next wave. Frequency is how many waves go past a point in 1 second. The unit measurement of frequency is hertz. The higher the frequency, the more energy in the wave. For example, if 10 waves go past in 1 second, it is 10 hertz. If 1,000 waves go past in 1 second, it is 1,000 hertz. If 1,000,000 waves go past, it is 1,000,000 hertz. Amplitude is how far the medium, crests and troughs, or compressions and rarefactions, move from the rest position. The rest position is the place the medium is when not moving. The more energy a wave carries, the larger its amplitude. The energy of a wave can be expressed by the equation E is equal to CA squared, where E is energy, C is a constant dependent upon the medium, and A is amplitude. Wave speed depends on the medium in which the wave is traveling. It varies in solids, liquids, and gases. A mathematical way to calculate wave speed is wave speed is equivalent to wavelength times frequency, or V is equal to F times lambda. So if a wave has a wavelength of 2 meters and a frequency of 500 hertz, what is its speed? If you got that the wave speed is 1,000 meters per second, then you're correct. Additionally, waves don't only travel in one direction, they can also change direction. There are 3 methods in which a wave can change direction. They can change due to reflection, refraction, and diffraction. Reflection is when waves bounce off a surface. If the surface is flat, the angle at which the wave hits the surface will be the same as the angle that the wave leaves the surface. In other words, the angle in equals the angle out. This is the law of reflection. Let's take a pool table, for example. When a pool ball strikes the side of a pool table, the angle at which it hits the bumper is the same angle at which it bounces off the bumper. Refraction is how waves can bend. This happens when a wave enters a new medium and its speed changes.
Later about the wave, this one. One more is there, simple video, we'll see. That will come across later.
I'm sure you're familiar with the word wave. You've probably moved your hand back and forth at a friend to wave hello, or watched the waves
your
break
hands,
at the beach. To those who study physics, a wave is much more than a simple greeting. Waves are disturbances that transfer energy from one place to another. Without waves, you couldn't see or hear. They're all around you. There are two types of waves, mechanical and electromagnetic. Mechanical waves have to travel through some type of matter, like air, water, or solid objects. This is because mechanical waves move when molecules in the matter bump into each other. These collisions pass on energy. Sound waves are a type of mechanical wave. Sound waves must travel through something to move. In outer space, past Earth's atmosphere, there is no air for sound waves to travel through. Because of this, there is no sound in space. It's completely silent. Other mechanical waves include ocean waves and seismic waves that cause earthquakes.
Seismic wave.
Electromagnetic waves do not have to travel through something. They can move through a vacuum, empty space, without any air, water, or solid objects. Electromagnetic waves don't rely on molecules colliding like mechanical waves. This type of wave moves through the charged particles in an electrical or magnetic field. Light is a type of electromagnetic wave. This is why light travels through outer space while sound cannot. Other types of electromagnetic waves include radio waves, X-rays, and microwaves. Waves can be described by how they move. Some waves move up and down as they move forward. Picture waves in the ocean. They are moving towards the shore. As they do, the height of the wave also rises and falls. This is an example of a transverse wave. Longitudinal waves move in the same direction that the energy is traveling, not up and down. Sound waves are an example of a longitudinal wave. It's important to note that matter does not move through waves, only energy does. If you place a raft into the ocean, it will bob up and down as the waves crest and fall. It will not move towards the shore unless other factors like current or wind affect it. Scientists can measure how much energy a wave has. Wavelength is the distance between the peaks or highest points of the waves. The closer together the peaks are, the shorter the wavelength and the more energy the wave has. Amplitude measures how tall or short a wave is from its peak to its resting point. A taller wave with a higher amplitude means more energy. This video was created by La Fontaine of Knowledge. Click the...
So we are clear about the what is exactly the wave and what are the different types of waves. Okay, so mainly after knowing about wave and wave motion, there are two major types of waves. One is mechanical waves, other one is electromagnetic waves. So mechanical waves are those which require medium for their propagation. Without medium, they cannot travel, such as sound waves. And second type of waves are electromagnetic waves, which can travel through even vacuum also. They are produced by both electric and magnetic fields when they pass perpendicular to each other. So among these mechanical waves are classified based on how they are propagating. Based on their way of propagation, they are classified into transverse waves and longitudinal waves. So transverse waves are the waves in which all the particles of medium travels perpendicular to the direction of propagation. See here, the first one, if you see, the first point, the direction of vibration of the particles is perpendicular to the direction of propagation. Whereas longitudinal waves, they are parallel to the wave propagation. So second one, the wave propagation is in the form of crust and trough. Whereas the wave propagation in the form of compression and rarefactions. Next, these waves can travel through solid and on surface of the liquids only. In the propagation of these waves causes change in the shape of the medium. When you do the disturbance, definitely change happens. These waves can pass through solids, liquids, and gases also, as the propagation of these waves causes change in the volume of the liquid. Then, as there is a no variation of volume, in this no variation of the density of the medium. Whereas there is a volume variation is there, density also changes. There is no difference in the pressure medium while the wave propagation. The propagation longitudinal waves causes the pressure difference. When is a compressions, more pressure, rarefactions, less pressure. But in case of this, there is no pressure difference. So these are the two types of mechanical waves. So another type also there, based on the limitation of motion. Next we'll see in next class the two more types of waves apart from the transverse and longitudinal, based on the way of propagation, how they are moving forward, whether they are moving the parallel to the wave direction or perpendicular to the wave direction. They are classified into these two categories, right? But based on the limitation of motion, if they are restricted for their motion, they are further named. There are different two more types of waves are there. We'll discuss in the next class. But before that, once again, you see, there is a very interesting difference about the longitudinal and transverse waves. Okay. So see, this is the transverse wave, where all the particles, if you see here, there are so many particles to be there. All these are the particles only. They are perpendicular to the original direction. Every particle is perpendicular only. You draw a line like this. Here, all are moving along same direction. See, here some part there is a compressed, right? Here some part they are rarefied. They are called compressions. These are called rarefactions. Whereas here, crust, trough, crust, trough, crust. Okay, trough. Particles vibrates in the direction perpendicular, parallel. Crust and troughs are formed. Compression, rarefactions are formed. Formed only on the solids and liquids, solids, liquid, and gases. Maybe elastic waves or non-elastic waves. Example, light waves and radio waves. Only elastic waves formed longitudinal. Do not create pressure in different mediums. Creates the pressure. Here there is a compressions are there, more pressure. Rarefactions, no pressure. But here, pressure is common throughout the medium. Right. So the distance between, one more point I can add. Distance between two successive compressions or rarefaction is called lambda, wavelength. Here this is the lambda or this is the lambda. Two successive crusts or troughs. Two successive compressions or rarefactions. Right. So this is clear about what is the longitudinal waves and transverse waves, which are based on the way of propagation. Okay. So this is today's topic. And next class when we meet, we'll discuss about the two more types of waves, which are based on their limitation. When the wave is restricted, what happens? Suppose I told one example. When rope is tied to the wall and another one is your hand. Suppose you pluck it. So it moves forward. After striking the wall, again it reflects back. Means it is a restriction between you and your hand and wall. That kind of waves, that kind of propagate forms two waves. One is progressive wave, other is stationary or digressive waves. So that we'll discuss in the next class, the comparison study also. So what are the kinds of waves which are found by limitation of the force? That is, see, this is wave is moving forward. After striking, again it's coming back. So this is called progressive wave. This is called degressive wave. These two together gives one stationary wave. So we have two types of another waves based on the limitation, progressive and stationary. So progressive wave is nothing but this only, transverse. But whenever it is limited for reason, it comes back as a stationary wave. That is overlapping. Superimposition we can call it. When the two progressive waves are superimposed, they gives stationary. Stationary is nothing but constant. Because it's a limit. That is why it's based on the limitation they are classified. Okay. So that we learn in the next class. See another difference also there about these two waves, which we are going to discuss in the next class. So what we learned till now in this chapter, in last 3 sessions, we started with what is sound, right? We know the reciprocal of sound is noise. Then how sound is produced, right? How sound is produced is very important. And then how sound is propagated or traveled. Propagated is very important. Next, wave. What is wave? What is wave motion? And parameters of wave motion or parameters of wave, which gives the wavelength, frequency, amplitude, time period, and velocity, wave velocity. All these are relation V is equal to n lambda. Okay, this all comes under the parameters of the wave. When wave comes, when disturbance created, all this will come into play. Right. Then today we discuss about the types of waves. In types of waves, there are two major, that is mechanical and electromagnetic. Again, mechanical waves are classified into two categories, that is longitudinal mechanical waves and transverse mechanical waves. And one more classification is based on the limitation, they are progressive waves and stationary. We'll discuss tomorrow. So they are complete picture what we learned in the last 3 sessions of sound and wave motion. Right? Hope you are clear. Once you go through the material when you get the time during E&D class or study hours, targeted study hours. So sound is a form of energy which is pleasant to hear. Which is pleasant to hear is called sound. Unpleasant to hear is called noise. So sound is produced by vibrating body. Every vibrating body produces sound. Once sound is produced, it propagates through medium, because sound required medium for propagation. Through medium in the form of wave. What is wave? Disturbance created in the medium. When disturbance is created in medium, the disturbance propagates. For example, in your classroom, 30 students are there. Last bench, one student is talking to the other one. If teacher won't care, okay, leave her. So the disturbance, what happens? It comes to next student. Then entire class will become noisy. What is happening here? The disturbance is traveling from one student to another students and entirely spread. Similarly, when you disturb the water, the energy transferred from one particle to another particle and sound moves to the other end. Right? In the form of wave. That motion is called wave motion. When the wave is moving, when the particles in the wave is transferring the energy, they possess wavelength, they have frequency, they have amplitude, they have some time period, and they have some velocity. All these are the parameters of the wave, which are given by the mathematical formula. Velocity is equal to frequency into wavelength. Right? Then, based on the way of propagation, the method of propagation, waves are classified into mechanical waves and electromagnetic waves. The mechanical waves are further classified into transverse and longitudinal based on the way of propagation of the particles. If all the particles vibrate perpendicular, they are called transverse waves. If all the particles are propagated parallel, they are called longitudinal waves. In transverse waves, crusts and troughs are formed. In longitudinal waves, compressions and rarefactions are formed. Right? So in the other way also there, based on the limitation, how far this wave is limited. Based on the limitations, the waves are classified into progression and stationary waves, which we are going to discuss in the next class. Right? So hope you all clear with the topic of sound and wave motion so far. So you can see the differentiation also, the work for today, differentiation between transverse and longitudinal waves, right? The table form. So that's all for today. And thank you very much, students. Thank you very much, all the participant branches. Thank you, all of you. Have a wonderful day. Thank you.